Uh, Hello, my name is Deepraj, and as a part of data analysis, today I learned one of most common and statistical method used to determine the strength and direction of relationship between two variables, and it is called as correlation analysis. Uh, this statistical method is particularly determine the strength and direction of the relation between two variables. It helps identify patterns, trends, and predict future occurrences by quantifying how variables are interdependent. So, for correlation analysis, we will cover the key concepts, the interpretation, or the Pearson's correlation formula. Also, with this, I will do one problem in the Excel, and we will find out the Pearson's correlation, that is R, and we will see types of correlation and different steps for conducting correlation analysis, what are the interpretations, and where it is used, like applications, advantages as well as disadvantages of correlation analysis, and most important, what is the key difference between regression analysis and correlation analysis. So we'll start with what is correlation. So as this is statistical method, I am repeating this one more time, that it is determine the strength and direction of the relation between two variables, that is x and y, and it helps to identify the patterns, trends, and predict future occurrences by quantifying how variables are interdependent to each other. So what are the key concepts for correlation analysis? So by calculating the R, we have the known range, that is from -1 to 1, and both -1 and +1, for -1 and +1, shows the strong perfect correlation, where -1 shows perfect negative correlation, and +1 shows the perfect positive correlation, where the 0 shows the no linear correlation in two variables. Then there are types of correlation. They are the same, like positive correlation. Both variables are increased together. Like we know that height and weight can increase, always increase together. So they are positive correlation, and uh, negative correlation, like price and demand. If price is increasing, the demand will decrease, and when demand will increase, the price will decrease. That is the kind of correlation, and it is a negative correlation. Then there is zero correlation, like shoe size and intelligence. It doesn't make any sense, right? Or your mobile type and uh, what you call mobile type and your weight. It doesn't show any relationship. So this comes under zero correlation. So what is correlation coefficient? That is Pearson's formula. It is R is equal to summation of xi minus x bar into yi minus y bar, divided by under root summation of xi minus x bar bracket square summation into summation of yi minus y bar bracket square. So what are the R? R is correlation coefficient. Xi is the value of x variable in the sample, and x bar is the mean of the values of the x variable, and yi is equal to values of y variable in the sample. Y bar is equal to mean of the values of the y variable. So I hope this formula is clear, and we will apply this formula in the Excel, and we will solve one example as well, and uh, that is part of our assignments. But I have solved it, and I will put down the link or Excel file or Drive link in the description, so you can access it or you can see it. So we will see first different types of correlation coefficients that are used. Uh, so as we see, Pearson correlation coefficient is used, and there are various steps for conducting correlation analysis. Like first, we need to identify the variables, which variables particularly need to be used for uh, to correlate, and then after we will collect the data, gather data through surveys, experiments. Then we will choose the appropriate coefficient, selecting on based on data type and distribution. Then we will calculate the coefficient, and we will interpret the coefficient. That is important part, as I learned, and I am learning. uh, so interpretation of correlation coefficient, perfect or strong, that is point 0.8, 0.8 to 1, that are perfect or strongest correlation, either on the negative side or the positive side, and strong is 0.5 to 0.79. Moderate will be 0.30 to 0.49, and weak 0.0 to 0.29. As we know that 0 has no correlation at all. So this range is the interpretation, and these interpretations can be differ on various platforms, various websites. Also, by the end of this video, we will see who on YouTube as well, and some articles which helps to understand better this concept. Uh, and what are the applications of the correlation coefficient? So it is used in economics and finance, business analytics, market research, medical research, weather forecasting. It is used in every sector, every area, to analyze different trends between supply demand, to develop marketing strategies, to predict weather patterns by uh, establishing the correlation between two variables. So what are the advantages? Advantages is to simplify the understanding of variable relationships, to facilitate decision making, useful in machine learning for feature selection as well. So we can find out that which two variables are needed for further analysis from the correlation analysis. And what are the disadvantages for this? The correlation does not imply on cause and effect, and outliers can skew result. Definitely, outliers are needed to be treated in every model or every method that can cause or that can screw the results. And it is has limited to bivariate relationship, and it has inadequate for complex relationships. What is the difference in regression and correlation? Correlation, as we know, that it measures the strength and direction of the linear relationship. I will highlight this part. And between two numeric variables. And regression estimates the relationship between dependent variable and one or more independent variables. So regression is cause and effect phenomena. Correlation shows that variable move together, and because they are affected in the same way by relationship between them. Uh, where regression is the outcome is result of changes in one or more variables. It can calculate values of random variables based on the values of fixed variables. And regression can also predict the magnitude of change in one variable, like how much the one variable is differing from the another variable. It can also predict from the regression model. And in regression, variables often change in different directions. Swapping the variables will change the result. In correlation, variables are more or less interchangeable. So they are interchangeable. Like you can do x variable, and in another model you can do that same variable in the y as well. So it can be interchangeable. This I understand it from the example that I solved in the Excel file. So we will do that as well. So we covered difference in regression and correlation, advantages, disadvantages, applications, interpretation, steps, Pearson's correlation coefficient formula, types, and the definition. Okay, so we will quickly see one example and we will solve it in Excel file. So we have given this question for our assignment, and in the question, uh, a professor is trying to show his students the importance of quizzes, even though 90% of the final grade is determined by exams. He believes that the higher the quiz grade, the higher the final grade. A random sample of 15 students in his class was selected with the data given below. So, what given in the uh, example is that the professor is trying to find out the final marks or the final averages are depend on quiz average, and he needs to check that by establishing the correlation. So we know the formula R is equal to summation of xi minus x bar into yi minus y bar, and we divided by under root xi minus summation of xi minus x bar square into summation of yi minus y bar square. Here it is given the formula. So we will apply this formula in our example and we will solve it through Excel. So I will quickly copy this data. We have two variables, quiz averages and final averages, and I'll create here quickly. So this is our x variable, and this will be our y variable. So we have a data. So first and foremost, for formula we need uh, what we need, mean or averages for each variable. So I will quickly cover the average tab. Yes, average is 79.2. Same here, it is 75.53, and we don't need this digits. Okay, so we know that these are our averages for each variable, and I'll highlight this. Okay, then by the formula we will find out uh, x I minus x bar, then y I minus y bar. Sorry. So what is xi minus y bar? X bar is equal to select x, then minus select average and freeze that, because that will be simultaneous for all the values. So this is minus 20 to 22. Then double click on that. Then it will give for all the values. Same will be done with y bar. But here this needs to be changed. This needs to be done in B, because y bar is our in the B column. Same we will do here. Done. Then by the formula we know xi minus x bar, yi minus y bar, but we need to find out summation of xi minus x bar into yi minus y bar. So in this column we will quickly insert that column is equal to xi minus x bar into yi minus y bar. Done. So these are the values, and here sum of all the values. So we know, so our first requirement, that is summation of xi minus x bar into into yi minus y bar. So this is done. Then we need to find out the square of each variable, each value. We will quickly note this. Or same. What we will do? We will square these values. For square, just type this formula, then you will get the squares. Quickly, same here. As you see, Excel is amazing that it automatically takes the formula, but you need to just check for the freezing and the other points. So we will do this. We don't need all the four variables here. Okay, we will do some of this and this as well. So for R, what is our total formula? Is summation of xi bar into xi minus x bar into yi minus y bar summation divided by square root of xi into x bar. So we got our correlation coefficient at 0.8619. We'll quickly connect it. 0.86 our correlation coefficient, and it is highlighted in blue color. So this is done, and we know that R value is 0.86. And for formula, you can see here what I have done. I have taken the summation of xi minus x bar into yi minus y bar. Then I divided by the of uh, square root xi minus x summation of xi minus x bar into yi minus y bar summation. So we got the R value, that is 0.86. And what it means, that 0.86, we know the interpretations, and for 0.86 is the perfect correlation. That means professor is right that quiz final averages marks highly correlate with the quiz averages marks. So uh, done, correlation analysis done, and I also solved some another examples here in this file for different questions. Uh, if you want, you can get this by accessing the link below. I thank you so much. Have a good day. Bye bye.